Hi, everyone. Thank you for joining us. Today we have Birds, Past, Present, and Future Part 1 with Michael and Emily.
Presentation, I'm going to be talking a little bit about dinosaurs, which you may or may not expect from me at this point. But did you know that dinosaurs never really went extinct? So we're going to start off about birds with that fun fact today. Um, so what do I mean by that? Now, most dinosaurs as most people know them, went extinct about 65 million years ago. Tyrannosaurus, Triceratops, duck-billed dinosaurs, they're all gone. But there are some dinosaurs that live on today. So if I showed you this and asked you what do these animals have in common, what would you be able to come up with? Well, so on the left we have just like a songbird, like a warbler, and on the right, of course, we have Dromaeosaurus, which is a dinosaur related to Velociraptor and Utahraptor. And if you look at these two, you can see some similarities. In fact, you might even think that this dinosaur on the right looks kind of like a bird. It has feathers like a bird. It looks like it has big wing feathers. Okay, so there are some similarities. What if I showed you Tyrannosaurus? Then you're like, what similarities could there be? Well, it turns out a lot more than you think. So first, kind of a history lesson of the research of birds and dinosaurs and how they're related. So back in the 17 and 1800s, dinosaur tracks were found in several New England states like New Jersey, Connecticut, maybe not quite enough in New Hampshire, but Massachusetts and Maryland. We found these large three-toed footprints all over the place. And dinosaurs were not known at this time by Western science. In fact, the word dinosaur wouldn't be coined until almost 100 years later. So when scientists in the 1700s were looking at these tracks, they concluded that they must have been left by giant birds because they're pretty big tracks, as you can see in this footprint next to this person's shoe here. They could be over a foot long, which is pretty sizable. And they have three toes called a tridactyl track. And when you look at the foot of a bird, its bottom is covered in scales. They have like those little claws. So it makes sense why you think if you don't know what a dinosaur is yet, you're like, oh, well, they're made by giant birds. And that would change, about 100 years later when we found out what dinosaurs were actually like. But fast forwarding to 1861, this is about 25 years after dinosaurs had become well known and popular. The Archaeopteryx is probably the most well known fossil and most fossil of all time, like easily, if we're talking about an individual single fossil. And this animal is what we call a mosaic. It basically has a mix of ancestral or primitive and what we call derived or advanced traits. Basically, it just means all that technical jargon just means it has a mix of dinosaur characteristics and what we think of as bird characteristics. So it has wings, feathers, and long arms like a bird, as you can see here. But it also has in its mouth lots of little pointy teeth, has claws on its fingertips, and it has a long bony tail like a carnivorous theropod dinosaur. And for future reference, since I'm going to be talking about them a lot today, the theropod dinosaurs were the bipedal carnivorous dinosaurs like T-Rex and Velociraptor and Allosaurus and so on. So my question for you is this animal a bird or a dinosaur? Now, if you're a little, if you don't know what to say to that, I don't blame you because it's been debated for 150 years, ever since this thing was discovered, what exactly it is. And it's gone back and forth in the technical literature since then, and the most recent analyses conclude that it is a bird, and so it's commonly seen as a primitive bird, but it has a lot in common with theropod dinosaurs too. So the bird ancestry, like what did birds evolve from, has been a question that's been heavily explored from the late 1800s through the mid 1950s. So William Beebe was a famous naturalist in the early 1900s in the U.S. He was almost like the Richard Attenborough of his time, very well known, very prolific writer. And he hypothesized that early birds went through what he called a tetrapteryx stage. It's from the words meaning tetra, meaning four, and pteryx, meaning wing, so four-winged. And so we thought early birds evolved from some kind of reptile. He didn't specify exactly, and that they were these four-winged animals, or they went through a stage of being these four-winged animals that would have glided tree to tree before losing those those hind wings, and becoming the birds as we know them today. Now he based this hypothesis on some embryonic and baby, like newly hatched birds that seem to have some long quills on the backs of their legs, and so he thought that was like kind of a vestige, something left behind from their ancestors. Now, then about 20 years later, in the 1940s, comes along a paleontologist named Gerhard Heilmann, and he is Dutch, as his name suggests. And Heilmann speculated that birds evolved from dinosaurs. Now, this wasn't a brand new idea. I mean, back in the 1860s, when Archaeopteryx was discovered, this idea was thrown around and eventually just kind of, left behind. But he revived the idea that birds evolved from dinosaurs. But he ultimately dismissed this hypothesis on account that dinosaurs did not have a wishbone. It's also known as the furcula. It's the collarbones that we have, except in birds and dinosaurs that they are actually fused. So because dinosaurs don't have wishbones, Heilmann said, okay, well then birds must have come from some other type of reptile or some other type of animal. And his work here, he was another very prolific writer. He wrote a whole book on this called The Origin of Birds, very well known. He wrote lots and lots of papers, and his this became the dominant view of bird origins for the next 4 decades. He was very influential. I mean, the debate on this topic basically ceased until the 1960s, when something pretty big happened, which I'll get to in a bit. But we've since discovered that theropod dinosaurs do have wishbones. And not only that, but I'm going to talk about this animal called Oviraptor. So when Heilmann was writing The Origin of Birds, this is big work on this subject, a dinosaur from Mongolia named Oviraptor was discovered. And this is an illustration from the original paper. And he actually looked at this paper and cited it in his work. I want to draw your attention to this bone. This bone has been identified as the interclavicle by the original author of this paper, by the man who discovered Oviraptor in 1924. So when we're looking at the history of science, there are a number of times where you can tell, and in hindsight is 2020, of course, but in hindsight you can tell when people were so close to the truth, so close to a fundamental aspect of reality that would like to have revolutionized the field, and then they just miss it by inches. This is one of those times, because this is not an interclavicle bone at all. This is actually a misidentified wishbone of this dinosaur. And so my mind immediately goes to, what if this bone was identified correctly to begin with? What if Heilmann had studied this paper with the same amount of rigor as he did his other sources? What if he actually went to New York in the 20s to study the specimen for himself? If he noticed this, his conclusions would have probably changed entirely, and we would have been, had another 40 years working on this hypothesis. And that became the predominant theory for decades. So fast forward to about 40 years later, in the looks like I'm breaking up a bit. Fast forward to the 1960s. The 1960s saw a revolution in paleontology called the Dinosaur Renaissance. And the Dinosaur Renaissance essentially changed how everyone, the public and scientists alike, saw dinosaurs. So we used to see them as these big, sluggish, brutish, cold-blooded reptiles, overgrown lizards, basically. But the Dinosaur Renaissance, we find some new evidence, some new dinosaur species that made us realize that these were active, hot, warm-blooded animals. And it was during this time, a little later, in the 1970s, where you can see the first speculative illustrations of dinosaurs reconstructed with feathers. And this wouldn't be very commonplace. Even at the time, feathered dinosaurs were kind of a very speculative and revolutionary thing. So you didn't see too many illustrations until the 90s. In 1996, there's a dinosaur named Sinosauropteryx discovered in China. Now, this was a pretty small dinosaur. They didn't get any bigger than 3 feet long, and this original holotype specimen is, very, very like the size of a cat. But do you see this kind of fuzzy, fluffy stuff on the back and the tail and the back of the head? Those are actually the first direct evidence of feathers or feather-like material on a dinosaur. And then going to 2003, less than 10 years later, we found Microraptor, another feathered dinosaur. But this one is different. This didn't have just like a little bit of fuzz along the back. This thing was covered nose to toe in feathers. And on the wings, it had these long, what we call pennaceous feathers. Those are the feathers we see in modern day birds that allow flight. Now, if you remember, this might look kind of familiar from something I mentioned earlier in the PowerPoint. This animal, Microraptor, is remarkably, stunningly, astonishingly similar to the Tetrapteryx animal that was hypothesized by Beebe in almost 100 years earlier in 1914. And I cannot stress enough that this animal at the time that he drew was entirely speculative. And William Beebe also was not saying that birds evolved from dinosaurs, but he was speculating that they went through a stage somewhat like this. And lo and behold, 85 years later, we find another four-winged, long-tailed animal. And this was huge. I mean, that's incredible. It turned a general hypothesis turned out to be a pretty accurate prediction. And so at this time, or actually back in the 60s, is when the idea that birds evolved from dinosaurs became big again and became pretty well established. And these feathered dinosaurs just absolutely cemented that fact. We found many, many more feathered dinosaurs since then. There are over 50 genera or 50 species of dinosaur that have been found with direct evidence of feathers, either the feathers themselves, like the impressions, or other like the inference of feathers by different bony structures. But so dinosaurs might be quite different than how a lot of people are used to seeing them. They weren't all these big, scaly British animals, but instead they basically looked like birds. Further, just this year, last month actually, in March of 2021, we discovered something we've hypothesized for a long time, but that dinosaurs actually sat on their eggs to keep them warm. But we actually found a dinosaur that was on top of its nest, which is really, really cool. Which that behavior sounds a lot like modern day birds, right? With more similarities of birds and dinosaurs. So we're going to talk about their respiratory system. That's how an animal breathes. Birds have incredibly efficient lungs. So they have something called unidirectional breathing. Unidirectional breathing basically means, so we're mammals, and when we inhale and exhale, the air goes in, and then it sits there, and then we exhale, and the air goes out as carbon dioxide. But that's not a very efficient process by any means. Birds, with their unidirectional breathing, even while they inhale and exhale, they're constantly getting fresh air through their body and through their lungs. So as they inhale, it goes into some air sacs in the back of the bird. When they exhale, it goes through the lungs. When they inhale again, a second time, it goes through the front air sacs. And when they exhale, it actually exits out of the body. And so birds need this incredibly efficient system so they can keep up with the demands of flight. But their bones also play a part in their process. The bones are hollow and have air sacs in them. And so birds actually use their bones to help breathe, which is really, really cool. But it turns out that dinosaurs have a similar system. So in 2009, this 30-foot long dinosaur, big theropod dinosaur called Arosteon was discovered. And Arosteon, the name means air bones. It's appropriate because this animal has a lot of evidence that we see in modern day birds of what we call pneumatic features in the bones. Basically, this guy also had air-filled bones. So we know even the big theropod dinosaurs like Eristheon and Allosaurus and Tyrannosaurus rex would have had a similar breathing system to modern day birds. And so as we go through all these criteria, you might start to wonder, is like, so it seems like dinosaurs and birds are a lot of similarities. So what exactly is the difference? And it turns out that what the difference is between a bird and a dinosaur is not as clear as it used to be, even 15 or 20 years ago. And the range of species that now fills the gap between dinosaurs and birds it's not like a stepwise transition. It's a gradient. It's a continuum between those groups. So there is no definitive point in time, no definitive feature where that we can use to distinguish between birds and dinosaurs. It's just, at this point, it's impossible. And this point is made even more evident when you look at species like these. All these are species that have gone back and forth in the technical literature between scientists thinking they're birds and thinking they're dinosaurs. So Archaeopteryx has bounced around a lot and is now considered a bird. Anchiornis is recently, several years ago, a paper came out that said it was a bird, even though originally it was thought to be a dinosaur. Balaur bondoc was thought to be a dinosaur that's very closely related to Velociraptor originally, but a more recent analysis says, oh, it actually turns out to be a bird. And kind of flipping the script on this, Alvarezsaurs, which are very weird little dinosaurs, were originally thought to be birds, but as we learned more about them, more about these relationships, we learned, okay, they're actually more on the dinosaur side of things. And so even with scientists, even with all this literature we have and all the bones we have, it's very difficult to distinguish what's a bird and what's a dinosaur, and it takes a lot of debate sometimes. And so these animals, as we see, are not so different after all. Dinosaurs, specifically theropods, have more in common with modern day birds than they do with reptiles. For example, they have a backwards pointing pubis, they have air sacs throughout their bodies, they have hollow bones, just like birds, they have wishbones, just like this little cockatiel here does. They're covered in feathers, just like Odie. And we know now that they actually brooded their nests to keep their eggs warm, just like modern day birds. So in summary, paleontologists have been drawing a connection between birds and dinosaurs for over 150 years, even longer if you consider the quote unquote giant bird trek that turned out to be dinosaur treks. So birds descended from theropod dinosaurs, which are the two-legged carnivorous dinosaurs like T-Rex and Velociraptor and Allosaurus. They share a large number of characteristics, so much so that it's hard to tell the two apart sometimes. And so that all comes down to the final statement that birds themselves are theropod dinosaurs, meaning birds are not just related to dinosaurs, birds are not just descended from dinosaurs. Those are both true, but that also means birds themselves are actually dinosaurs. And so if you went back in time and saw some of these dinosaurs, at first glance, you might think they're birds. And so I hope that helps change the way you see dinosaurs a little bit. And birds, for that matter. And so now I will pass things over to Emily, who's going to talk about the more modern side of things.
Yeah, thanks, Michael, and thanks, little Odie. I was wondering what that sound was throughout your recording. Good to know that it's a little parakeet or cockatiel. Which one? Cockatiel, right?
I'm kind of scared. I'm gonna leave them alone.
All right. So I am going more on the conservation side of things, and so introducing a topic that doesn't necessarily bring to mind birds at first, but you'll see where birds come into play here. So I want to focus, this being April, it's Earth Month, I want to focus on Rachel Carson, who was an extremely influential conservationist, environmentalist, before that was even really a thing. And so and so she wrote a book. She wrote many books, but her most famous book was called Silent Spring, and she published it in 1962. And its main focus was on the environmental damage that we as humans are doing, and especially the effects of pesticides and agriculture and farming, and how we need to be aware of how our choices as consumers, as when we go shopping or whatever we are intending to purchase, we need to be aware of how that affects the world beyond ourselves. And so the public at the time not aware of the ecological damage that just general agriculture, the vegetables that you go buy at the grocery store, the way that those are farmed can vary and can have completely different effects based on how responsible and how careful the farming practices are. So ultimately, Silent Spring's publication in 1962 is what eventually led to the establishment of Earth Day. So let's dial that back a little bit. Shortly after she wrote Silent Spring, it was immediately popular. It was immediately something that grabbed the public's attention and was recognized as an issue that affects everyone. And so even President at the time, John F. Kennedy, was inspired by the message that she was putting out, and she was called to testify before Congress because the government decided that they need to begin to take measures to limit the kind of ecological damage that we were doing. So in 1963, she testified before Congress, and President Kennedy created a commission to review the pesticide policy that the government allows and the kind of leeway that these agricultural industries are able to go outside of regulations and what kind of regulations need to be in place. And so by 1970, it was an extremely widespread issue. It was very well known across the country, and there were various groups that were leading protests, and there was a widespread environmental activist movement that by April of that year led to the establishment of Earth Day. And the very first Earth Day in 1970, 20 million Americans gathered together and had a peaceful protest and stated their opposition and stated their willingness to have the government change the policies, their desire for the government to change the policies. As taxpayers, as voters, they have a right to speak out against these things and say what they want their representatives to do for them and for the environment. And the Environmental Protection Agency was then established by the end of that year. So before 1970, before the first Earth Day and all of these public awareness campaigns, there was no agency in the government that actually worked for environmental protection. And they were established specifically with the purpose of protecting human and environmental health. So what does this have to do with birds? Well, Rachel Carson brought attention to a variety of pesticides, but the one that was most striking to people and that was most widely used was DDT. And DDT is now infamous because it is so well known as a detrimental toxin. But at the time, nobody was really talking about this. They didn't realize that shortly after World War II, even the government and farmers were spraying DDT without thinking twice about it. It was a mosquito control. It controlled agricultural pests so that there was less crop damage by insects. It was just a well used and little thought of insecticide. And so, like anything that we spray on our crops or add to our crops, when it rains, when we water that land, it washes into the channels, into the rivers, and washes out to sea. And all aquatic ecosystems are then affected by it. It goes where water takes it, it spreads and it disperses. And so as the plants in these water systems were taking it up, the fish were then eating these plants. It was accumulating in the fish, and then birds would eat the fish, larger marine mammals would eat the fish, and it would then accumulate in their tissues. And it especially builds up in fatty tissues. So you think salmon or fattier fish, it would be especially concentrated in that tissue, and things that eat those would be more prone to then taking that in and accumulating it in their tissue. So salmon eaters, and really any fish eaters, any birds that are dependent on an aquatic ecosystem for their food source are then damaged by this DDT, which is especially bad for their eggs. And so DDT is damaging in general, but especially for birds, it actually blocks the calcium uptake, and it blocks the ability to produce eggshells that are strong enough to keep the eggs safe during incubation. And so they would lay the eggs, but they were so brittle that the adult themselves would break them, and these chicks were not able to hatch. So there were years and years where these birds were not able to have any offspring because their eggs were not able to hatch. And bald eagles, which were quite symbolic and are quite symbolic as the symbol of America, the representative of the nation, were especially hard hit. They are very much there was an official Endangered Species Act created by the government and by the now Environmental Protection Agency, the Fish and Wildlife, in 1973, 6 years later. And at that point, they were actually afforded protection. So restrictions were applied that allowed them to be protected through this Endangered Species Act. So through the Fish and Wildlife Service and its partners, there was a very widespread effort to protect the bald eagle. And that was the image, that was the charismatic animal representing the plight that all birds were facing from DDT. And so the Endangered Species Act allowed them to be brought in. They started captive breeding programs. They bred them in captivity so that they were safe from this DDT, and then they reintroduced them to where they belong. They were protecting the nests. They were giving them greater resources and just overall protecting their ability to reproduce. And so ultimately, we can say that Silent Spring was absolutely invaluable for bald eagles continuing to exist. They were severely endangered shortly after and at the time of publication of Silent Spring, and it really set the stage for them to come back and to repopulate. And now bald eagles are kind of everywhere. They weren't the only species impacted, though. Like I said, birds were affected far and wide. Peregrine falcons, these beautiful guys, were on the brink of extinction. The brown pelican, the Mariana crow, different species of falcons and swifts and condors, the California condor, the wood stork. So a lot of these animals, these birds that eat larger prey items, larger fish and mammals that are more likely to encounter and concentrate the DDT in their bodies. So in 1972, at the very end of the year, the Environmental Protection Agency effectively banned DDT. And so that was a huge step forward in environmental protection in general. And it was only 2 years after the Environmental Protection Agency was established. So you can see that having these government bodies there to enable these protections to be put into place is critical to the protection of wildlife. So we need to do what we can as an individual, but we also need to inform policy, and we need to influence people who represent us in a greater capacity to take these measures on our behalf. We need to let people know that these are concerns that more people are thinking about. And so that peregrine falcon, in 1975, there were only 39 breeding pairs in the entire continental US, and all of them were on the West Coast. So peregrine falcons in the eastern US, where you can actually, it's amazing, they take so well to city dwelling and in skyscrapers. So if you have an interest and have a moment, Google peregrine falcons in cities, because it's remarkable the way that they're able to hunt and live in skyscrapers. So peregrine falcons were nearly eradicated in 1975. 20 years later, there were 993 pairs in the continental US, 21-fold increase, and they have absolutely come back to the eastern half of the United States. They are widespread across the country. And the brown pelican, which was also endangered, only 10 years later, recovered to 5,000 pairs along the Atlantic coast, where it was nearly eradicated. And it was able to be removed from the endangered species list by 1985. And so our bald eagle, our symbol of America, is doing tremendously well. They are almost a nuisance. There are so many of them in areas like Alaska and Florida, and they steal fishermen's fish, and that it is you can see flocks of them. And so here was when Silent Spring was published. DDT was banned by that third bar there, and as the years have gone by, they have only increased. So environmental activism absolutely works. And like our friend the Lorax said, unless someone like you cares a whole awful lot, nothing's going to get better. It's not. So April is Earth Month. I think it's a good time to bring light to these conservation issues, and it's an everyday occurrence. It's something we need to pay attention to and care about every day. But for the month of April, especially so, recycle, do your part. And April 22nd is Earth Day. So if you're not already celebrating throughout the entirety of April, April 22nd is the day to do it. That is Earth Day, and this is the 51st annual Earth Day, after that very first one inspired by Rachel Carson in 1970. So I will leave it at that, and I thank you all for tuning in. I hope you learned a lot about bird dinosaurs and dinosaur birds, and why those birds are so important to protect, and why we need to protect the environment in order to protect everything we care about within it. So bye, Odie, and